The International Space Station, ISS, is a marvel of modern engineering, serving as a space-based laboratory, observatory, and living quarters for astronauts. It provides a platform for international cooperation and enables human space exploration by conducting research in microgravity across various disciplines such as biology, physics, and astronomy. Orbiting Earth at an altitude of approximately 400 kilometers (250 miles) and traveling at a speed of 28,000 kilometers per hour (17,500 miles per hour), the ISS completes one orbit roughly every 90 minutes. The ISS is one of the largest human-made structures in space, spanning approximately 108 meters (356 feet) end-to-end. Its interconnected pressurized modules, external trusses, solar arrays, and docking ports include key components like the US Laboratory, Destiny, Japanese Laboratory, Kibo, European Laboratory, Columbus, and Russian modules, Zarya and Zvezda, alongside connector modules such as Unity, Harmony, and Tranquility. The station is powered by 8 large solar arrays, which convert sunlight into electricity stored in rechargeable batteries for use during periods of darkness. Living on the ISS requires adaptations to microgravity. Astronauts sleep in small, phone booth-sized quarters, securing themselves in sleeping bags to prevent floating. Meals are pre-packaged and often dehydrated, requiring rehydration with water, and hygiene is maintained with wet towels and no-rinse soap since showers are not feasible. Waste is managed using suction-based systems in bathrooms. To counteract the effects of microgravity, such as muscle atrophy and bone density loss, astronauts exercise daily for at least 2 hours using treadmills, stationary bikes, and resistance machines. In their free time, they read, watch movies, or enjoy views of Earth from the cupola, a panoramic observation module. The ISS facilitates groundbreaking scientific research in its microgravity environment. This unique setting allows for studies in biology, such as how cells and plants adapt, physics experiments like observing fluid dynamics and material behaviors, and astronomy research free from atmospheric interference. The station communicates with Earth via satellites, ensuring constant contact with mission control, while its orbit is periodically maintained with boosts from visiting spacecraft or onboard thrusters in Russian modules. The ISS was constructed over several decades, beginning in 1998 with the launch of the Russian module Zarya. It was assembled in orbit by international space agencies, including NASA, Roscosmos, ESA, JAXA, and CSA. Spacewalks and robotic systems, such as Canadarm2, were used for construction and maintenance. The station is regularly visited by spacecraft like SpaceX's Crew Dragon, Russia's Soyuz, and previously NASA's Space Shuttle for crew transportation, while cargo resupply is handled by vehicles like SpaceX's Dragon, Northrop Grumman's Cygnus, and Japan's HTV. Astronauts perform extravehicular activities, spacewalks, to repair, install, or maintain external components of the ISS, using specialized suits equipped with oxygen, temperature regulation, and communication systems. Despite its achievements, the ISS faces challenges, including the effects of microgravity on the human body, exposure to radiation, and the risk of collisions with space debris, which sometimes necessitate orbital adjustments. The ISS is expected to operate until the 2030s, after which it will be decommissioned. Plans include a controlled descent into Earth's atmosphere, with remaining fragments landing in the ocean. The future of low Earth orbit operations may rely on the development of commercial space stations. As a testament to international collaboration, the ISS advances our understanding of space and prepares humanity for future exploration missions to the Moon, Mars, and beyond. The International Space Station, ISS, is a remarkable symbol of global cooperation, involving 5 major space agencies: NASA, United States, Roscosmos, Russia, ESA, European Space Agency, JAXA, Japan Aerospace Exploration Agency, and CSA, Canadian Space Agency. These agencies work together in sharing responsibilities for research, logistics, and station maintenance. The ISS operates under a multilateral treaty and agreements formed in the late 1990s, which outline resource sharing, funding, and research allocations. The annual cost of the ISS is estimated at around $3 to $4 billion, with funding contributions shared among participating nations based on their level of involvement. The research conducted aboard the ISS has led to significant advancements in various fields. In medical research, studies on osteoporosis and muscle atrophy in microgravity have contributed to treatments for age-related bone loss. Protein crystal growth experiments in space have enabled the development of better drugs for diseases like cancer and Parkinson's, while studies of the immune system in space offer insights into autoimmune disorders. Technological innovations such as water recycling systems, advanced robotics like the Canadarm2, and 3D printing in space are providing practical solutions with applications on Earth, including clean water systems and advanced surgical technologies. The ISS also plays a critical role in Earth observation and climate studies, housing instruments like EcoSTRUS and OCO3 that monitor the Earth's surface temperature and carbon dioxide levels, contributing to climate change research and disaster response. Additionally, astrobiological research on microorganisms and long-duration human missions helps prepare for future deep space exploration, such as Mars. Increasingly, the ISS is opening up to private companies and the public. SpaceX and Boeing have partnered with NASA to reduce the cost of human access to space, and private industries conduct valuable research aboard the station. Space tourism is also becoming a reality, with companies like Axiom Space and SpaceX facilitating missions for private citizens to experience life aboard the ISS. Moreover, the station serves as an educational tool, with programs like STEM on station allowing students to interact with astronauts and learn about space science. The ISS has led the way in sustainable living technologies, pioneering systems like the water recovery system, which purifies wastewater into drinking water, and the oxygen generation system, which ensures a continuous supply of breathable air. Solar panels with advanced tracking systems ensure maximum energy efficiency. Safety systems aboard the ISS include meteorite and debris protection through external shielding and tracking systems that allow the station to avoid potential collisions with space debris. Fire suppression systems and emergency evacuation protocols further enhance the safety of the crew. Docked spacecraft, like Soyuz and Crew Dragon, serve as lifeboats in case of emergency. The ISS also has a lasting legacy and future impact on space exploration. NASA and its partners are using lessons learned from the ISS to develop the Lunar Gateway, a small space station in lunar orbit which will serve as a stepping stone for future missions to the Moon and Mars. The ISS has been essential in testing life support systems and understanding how humans adapt to long-term space missions, providing crucial data for upcoming deep space endeavors. Private companies like Axiom Space and Blue Origin are planning to build commercial space stations for research, manufacturing, and tourism, utilizing the technologies and expertise developed aboard the ISS. Culturally, the ISS has inspired people worldwide. The station has hosted cultural projects, including music performances, art exhibitions, and even films shot in microgravity. Astronauts frequently share stunning images of Earth from space, fostering a sense of unity and raising awareness of the planet's fragility and the importance of environmental conservation. The ISS stands as a testament to the possibilities of human ingenuity and collaboration, making invaluable contributions to science, technology, and humanity's understanding of space. It serves as a cornerstone for the future of human space exploration and the dream of becoming a multiplanetary species. Thanks for exploring the cosmos with Space Universe 016. If you enjoyed this journey, make sure to like, share, and subscribe to stay updated on all our interstellar adventures. I'd love to hear your thoughts, so drop a comment below, and let's continue unraveling the mysteries of the universe together. Until next time, stay curious and keep reaching for the stars with Space Universe 016.